welcome back, folks. Today we're going to talk a little bit about something called variation. So variation is the difference between what we call true north and magnetic north. And this difference is the difference between essentially the magnetic pole of the Earth and where we draw our lines on the chart. So if we look at a chart like this, the top and the bottom of the charts refer to the North Poles and the South Poles. However, when we're dealing with compasses, whether they're compasses like this on your boat, binnacle compasses, or your autopilot compass, your flux compass on your vessel, they are pointing to something called magnetic north. That discrepancy between those 2 points, it is in fact a form of error that needs to be calculated when we're working our courses out on the chart. So if we have a look here a little bit close on the chart, normally and on most charts you'll find something called a compass rose. And generally speaking, there'll be actually several on a chart, but this is what a compass rose looks like. And if we look at the compass rose in here, and if I just circle this with my pencil, you can see that here, in the area that we're sailing, Moreton Bay, the variation between what we call true north, as in where the chart points to, and where the compass points to, that variation there is roughly almost 11 degrees east. In other words, the compass itself is pointing in a slightly different direction to where we would draw the lines on the chart. Now, 10 degrees when we're going a couple of miles is, you could argue, neither here nor there if we're doing short journeys out in the bay, as we often do here from the sailing school. However, if you're crossing an ocean, 10 degrees from one side of the planet to the other is a huge difference. That variation is relative to the top of the pole, in other words, the axis of the Earth, and will therefore change depending on where you are on the planet. We're going to just look at how we work out that discrepancy. So if we grab a piece of paper here, and we would say, let's say for argument's sake, that we wanted to go at 90 degrees on the chart. So we've drawn a line on the chart. We want to go from where we are here in Brisbane, and we wanted to sail to the other side of the bay, which happens to be precisely due east. We would mark it with a little bit of a T in a bracket there, just to make sure that we are aware that that calculation was in what we call true. So anything that we do on the chart is referred to as true, and anything that we do with the compass is, anything after that, any magnetic calculations after that would be referred to as magnetic. So we would refer to those with a little m in brackets. We would then take that 90 degrees and we would look at the 10 degrees 55 minutes east, and we would minus that from the 90 degrees. There's an easy way to remember which way to aim the calculation, and it's a way that I was taught when I was a younger person, and it's east is least and west is best. In other words, anything that is east, or any error that is east, we minus it from the true, and anything that is west, we would add it from the true. So east is least and west is best. And I found over the years that that's a really easy way to remember it. So 90 degrees, 10 degrees and 55 minutes, remembering that each degree has 60 minutes, therefore 55 minutes is almost a degree, so we're going to turn that 55 into a full degree, so that would be in fact 11 degrees east. So we're going to minus 11 from our 90, and that would be, my maths is terrible by the way, but I believe that's 079 degrees true. So that would be our course to steer in magnetic. I hope that makes sense. Conversely, if we were taking some sort of a fix out on deck, or we were looking at our deck compass and the helmsperson said, I'm steering 180 degrees, for example, that would obviously be, of course, on the compass. We would then, instead of minusing the variation, we would have to add the variation, because in that instance, we would be going from the compass course to the true course. So let's say they said 180, I'll just write that down for you. So 180 magnetic, we'll come on to compass in a moment because that's something slightly different again. And instead of minusing the 11, we would add the 11 degrees, and that 180 magnetic would turn into 191 true. And that's the number that we would then use to draw onto the chart. So you would usually do that if you were sort of updating a passage plan or putting a fix on the chart or something like that. I hope that makes sense. Now there is one more bit of the calculation that we cannot ignore, and that's something called deviation. Now deviation is any kind of interference that you might have on your compass from any ferrous metals, mobile phones, sometimes even sunglasses or hats, cockpit speakers, the engine, metal boats, for example, all have an influence on the compass which can throw it off slightly. So on your vessel, you should have, if you haven't already got one, make or have a compass swinger come on board and make you a deviation card. And what they would do, they would take the boat out and they would point the boat in various directions and they would write down the deviation error for each of the courses that the boat steers. Now I'll give you a little example here. Can you see the difference that that makes on the compass with a mobile phone? A full, easily 20 or 30 degrees of difference. Now obviously, a mobile phone is a movable object, but it could be in your pocket, could be on your person, and that has a huge influence on the compass. So the deviation card cannot take into account all the movable objects, but it can take into account all the objects that are static on the vessel. Once again, cockpit speakers, bars around near where the compass is held, the engine on board, all those kind of things. So you'd have a deviation card. And in the same manner that we applied the variation, we would do exactly the same with the deviation, adding or minusing. And if you want to see an example of what a deviation card looks like, in this training almanac here, we have an example here of what a deviation card looks like. So we can see here from the card that at 0 degrees, if the boat is pointing 0 degrees, the deviation would be 4 degrees west. So remembering east is least, west is best, we would add the 4 degrees to our true calculations after, of course, adding or subtracting the variation, and that would give us a slightly more, once again, precise calculation for our course to steer. I hope that makes sense. Let's just recap for a moment. So when we're going from the chart to the compass, there are 2 errors that need to be thought about and included into that calculation. They are variation and deviation, and you add them in that order. So you go from the chart to turning it into a magnetic calculation, and then, so that would be your compass rose on your chart, and then from that number, you would then add or subtract further to that your deviation. And each boat will have a different deviation, whereas the variation is location specific. So just depending on where you're sailing, you'd find your compass rose, closest compass rose, and apply that, but your deviation will be boat specific. I hope that makes sense, and I hope you found this video useful, and we'll see you next time. Do you nose breathe?
Do I nose breathe?
We're supposed to nose breathe. It's good for you, apparently.
Oh, okay. Well, that's a yoga thing.
Yeah.
Yeah.
There you go.
I'm the Zen master.
Mm-hmm.
Yep. Got it.
Variation.